Here's example 8, another system that is perfectly set up for us to jump right in using substitution because the second equation is already solved for y. So I'm going to substitute it in to the first equation. So the first equation, we have 10x minus 5y is equal to 30. I am going to replace the y that is in that equation with 2x minus 6 because I know that that's what y is equal to. Please make sure that you're using parentheses when you do that because you will need to distribute that negative 5. So we have 10x minus 10x plus 30 equals 30. So the 10x's cancel and we're left with 30 equals 30, which is something that is true. It doesn't really tell us much about the system, but that is a true equation. So what that means when you do some kind of substitution, or this could even happen in the addition method, if you arrive at an equation is true, like 5 equals 5, negative 6 equals negative 6, that means that your system is dependent. If you remember the vocabulary we were going over at the beginning of this lesson, what it means that this is a dependent system is that these two lines are the same line. So if you were to graph this, in fact, let's graph it because all we really have to do is graph one of them because they're the same line. I'm going to graph the second one because it's already, by the way, think about it for a second. What form is this in? That is in slope-intercept form. It's already in slope-intercept form. I can see that the y-intercept of this line is negative 6, the point 0, negative 6, and I know that the slope of that line is 2. So what I'm going to do is I'm going to go ahead and just plot the point 0, negative 6. The slope is 2, so I'll go up 2 over 1, up 2 over 1, up 2 over 1, just getting me some points that are on this line, and then I will connect these points like this. So that's the graph of the second line. And just for emphasis, this is the graph of the first line. They are the exact same line. So now how do we write our solution when we have two lines that are the same? Remember, our solution is where the lines intersect. These lines intersect in infinitely many places. Any point on the line is going to be a solution. Any point on the line. So I need to generate a set of all the points on the line. Well, all the points on the line can have any x coordinate. Right? I can pick any number for x. And then to get the y coordinate, I just need to plug the x coordinate into the line. And the line is 2x minus 6. So as long as the point is x comma 2x minus 6, which is the equation of the line, it's going to be on that line. And I'll add the condition here, x can be any real number. So this is our answer. And what that represents is it is the set of all points that are on the line, because the lines intersect everywhere because they are in fact the same line. And you will always be dealing with a dependent system if you do some kind of elimination or substitution or addition and you arrive at an equation that is true. If we were to have gotten something like 15 equals 30 or 29 equals 30 or something that was not true, that would mean that our system would have been inconsistent and we would have had no solution.